students. So this is our video that follows the introduction to the rates of change, where we coupled it up with the chain rule. So if we were to specifically tackle the rates of change, so this is what I'm saying, that if y is a differentiable function of x, or if y is a function of x so that it is differentiable, in other words, if it is a differentiable function of x, dy dx exists. You're there, such that if x is also a differentiable function, if x is a differentiable function of another variable called t, if it is a differentiable function, function of another variable, maybe I can call it t. You're there. In other words, the dx dt, you're there. In other words, the dx dt exists. You're there. Then I have audacity now to talk about dy dt. I can talk about, since y is a differentiable function of x, dy dx exists, and x is a differentiable function of t, then dy dt exists. In other words, this can be obtained by the chain rule, that the dy dx multiplied by dx dt, mathematically I will not have changed anything because this and this can still disappear. We go back to dy dt. Yeah, such that, so that is what, this is one of the mega principles we shall be using in rates of change, whereby our t is going to be standing for time. It's going to be standing for the time perspective. So our example, okay, so here we have an example that the side of a tube is increasing at a rate of 6 centimeters per second. The side here is increasing. So they want us to find the rate of increase of volume when the length of each side of a side is 9 centimeters. That is a very simple one to understand. So if I try to draw for you guys the tube, now whether I can draw a proper tube, let me assume so, that I can draw a tube that you guys can say that that's really a mathematical tube. See, assume that such a thing, let us use it to represent a tube. They are telling us the side of the tube is increasing, so we can let the side be x. If I let each side to be x, this one x and this one x, what do I know about volume of a tube? Volume is s cubed, or side cubed, and for this case it is simply x cubed. You're there. So they want us to find the rate of change in volume, right? Meaning they are interested in how the volume dv dt, how the volume is changing with respect to time. This is what is required. But then what are we given? We've been given how the side is changing, dx dt, how the side is keeping on changing with respect to time, and this has been given as 6 centimeters per second. Now what we do here to get dv dt, what we do is we use the chain rule. So I want dv dt, which I can now use as the differentiation of v with respect to x, dv dx, multiplied by what have been given, dx dt. Allow me apply some economics here. See, mathematics and economics go hand in hand. So dv dx, but then I have v in terms of x, meaning that my dv dx, I differentiate this guy such that this is going to be 3x squared, such that my dv dt will equal to dv dx, which is going to be 3x squared multiplied by dx dt. Dx dt is 6, this guy is 6, meaning that this one is going to be 18x squared. So what about when my x is equal to 9, if my x is equal to 9 centimeters, I'm going to have my dv dt as equal to, I'm going to have this as an 18 multiplied by 9, and 18 multiplied by a 9, that is going to be squared, which is 81 So if you press a calculator, 18 multiplied by 81, that goes to what? That goes to 1458, and then this is a change in volume, cubic centimeters per second, as my value of dV dt. Hope guys we are together, and I'm not leaving anyone behind. So we have our next question, that a container in the shape of a right circular cone of height 10 centimeters and base radius 1 centimeter is catching the drips from a leaking tap at a rate of that is how the volume is changing. Find the rate at which the surface area of the water is increasing when the water is halfway up the cone. So as part of our solution, we have that if we can try to sketch out the cone, the right circular cone, it means its base is a circle, then it is perfectly right circular, such that we have here water. We have water that is dripping from a tap and is trying to fill up the cone, but then they are saying that this water is halfway up the cone. We've been told that this guy from here to here is at 10 centimeters. I think it is at 10 centimeters. Then so we have, and the base radius, we have this guy and the base radius, the base right circular cone in the shape of height and base radius. Its base radius here of the right circular cone is I think a 1, and then from here to here this can be an R. A radius of this one, this guy is 1, and then from here to here this is halfway, right? From here to here, you guys allow me call it H. Yes, so I have such a setup that this is the radius, the height, this is going to be 1, this is 1 centimeter, such that as part of our solution, if I use similarities such that I create one relation that is getting either the height or involving the radius. So if I'm to use similarities, by similarities, if I get the radius of the small cylinder divided by the height of the small cylinder can equal to the radius of the big one divided by the height of the big one. In other words, my radius is going to equal to 1 out of 10 h. 1 out of 10 h, such that if I can first chill that at that point, I've been given dV dt. Hope you guys can identify dV dt as 0.1 cubic centimeters, the volume, how it is changing with time. So find the rate at which the surface area, they are interested in dA dt. dA dt, if I let A to be my surface area, they're interested in dA dt. So this is what they are interested in. But then how can I have dA dt? dA dt can equal to dA in terms of either dA. Since I've expressed radius in terms of h, let me use dA dh multiplied by dh dt. But then I have I know the area. I know that surface area is the area of the circle, because it is the circular end that is increasing, meaning my area is equal to pi r squared, right? Such that I can replace this one by the value of h, which is this guy, such that this is going to be pi into h out of 10 squared, meaning it is pi out of 100 h squared as my area. In other words, my dA dH is the same as, if I differentiate this guy, I'm going to get pi out of 50 of h. When I differentiate the h squared, I drop the 2, reduce the power by 1, so I get pi out of 50 h. I can first show this guy at that very point, and still, so that not to confuse you guys, allow me to try to bisect here such that we can follow jointly together, such that I have now the dA dH, the dA/dH, so I'm interested in dH dt is the one missing for me to get dA dt. So now I still have now another relation to use is the dV dt, right? So I can have my dV dt. How the volume is changing with respect to time. So my dV dt is the same as, it can be the same as dV dH multiplied by the dH dt that I want, dH dt. And remember, I know the value of this one. I can get this one from the formula of volume. I know that volume of a cone is equal to a third pi r squared h, right? So this is the same thing. This is the same as a third into pi r squared. This is the same as pi r in terms of h is an h out of 10, and then this is squared h, meaning this is the same as pi out of 300 of h cubed, such that this is the volume now in terms of h, such that I can have this guy, I can have now the dV dH as equal to the dV/dH as equal to, differentiate this is 300, the dV, because this is 10 squared, which is, so if I differentiate this guy, this still goes to pi out of 100 of h squared. When I lower this guy, then I reduce the power by 1, I come to this guy. So this is the dV with respect to h. So I can put it here such that I get the dH dt, then I know the value of this guy. This guy is 0.1, so I can have there 0.1 will equal to pi out of 100 is going to be h squared, then dH dt. I can multiply everything this side, this one, if multiplied this side, I see, I think a 10 out of pi h squared is equal to dH dt is equal to dH dt, such that now I can come for this part, this one, I've already gotten the dH dt that I was needing here, so I can get the dA dt, such that now for dA dt, can say for dA dt, which is equal to dA dH is here, which is going to be pi out of 50 h, then multiplied by this guy, which is going to be a 10 out of pi. Then what will be the value of h? Remember, they've told us already that drips from a leaking tap at rate rate at which is increasing when the water is halfway of 10 is 5, meaning our h initially is 5, so you can put there the 5, or you can the h squared, 1h can cancel with this, such that I replace this remaining h by a 5, then I have the pi and the pi going, then I have now this 10 and this 10, such that I remain with a 1 out of 25, and 1 out of 25 is, I think, is it 0.04, and this is centimeters squared per second. Yeah, so the work is a bit shrugged, but I wanted you guys to follow up. Yeah, I didn't want to turn pages for you guys to, you could maybe not follow up clearly, but hope you've understood. We are combining the dA dt, we get it, we put it aside, then use dV dt with the definition of dV dt in terms of chain rule, it's dV dH and then dH dt. Yeah, so try to follow up, and anywhere where you find a problem, I said you can inbox me privately and I explain to you. Yeah, otherwise don't be selfish, tell more friends, yeah, to subscribe and then uplift or step up their mathematics. Otherwise, thank you.